Sometimes we have to test more than one condition. Consider the example of a discount applied to bulk purchases. 1% discount if the quantity purchased is less than 100 units, and 2% discount if the quantity purchased is between 100 and 250 units, and 4% if the quantity purchased exceeds 250 units. The cell range A8 to B16 has the data on orders. We want to construct an if statement that applies a discount percentage based on the quantity purchased. The first step is to determine how many if conditions do we need in the if statement. One if condition should test if the quantity purchased is less than 100 units or not. Another if condition should test if the quantity purchased is between 100 and 250 or not. There's no need for a third if condition, because if both of the above two if conditions return false, then it means the quantity purchased is more than 250. Let me show this by actually constructing an if statement in cell C9. I'm going to hard-code it to make the point clearer to you. You do not hard-code while solving the problem. It is not the best practice. Later, I will replace hard-coded values with cell references. I will write if statement to test the first condition, 1% if quantity less than 100. If, open parentheses, B9 less than symbol 100, comma, 1%, comma, 2%, close parentheses. Remember, B9 is less than 100 is the condition, 1% is the value if true, and 2% is the value if false. This if statement applies discount rates correctly if the quantity purchased is less than 100 and between 100 and 250. But it is not applying the correct discount rate for purchase quantity of 250 or above. We have to make it discriminate between quantities between 100 and 250 on the one hand, and 250 or above on the other. Now, I'm going to construct another if statement. If, open parentheses, B9 is less than 250, comma, 2%, comma, 4%, close parentheses. Remember, B9 less than 250 is the condition, and 2% and 4% are values for true and false outcomes respectively. Finally, I'm going to merge these two if statements into one single nested if statement. I will substitute the value for one of the outcomes in one of the statements with the other if statement. First, let me consider replacing false outcome in if, open parentheses, B9 less than 100, comma, 1%, comma, 2%, close parentheses. I'm going to replace 2% with if, open parentheses, B9 less than 250, comma, 2%, comma, 4%, close parentheses. The new if statement will be if, open parentheses, B9 less than 100, comma, 1%. If, open parentheses, B9 less than 250, comma, 2%, comma, 4%, close parentheses, close parentheses. This is called a nested if statement, as it has a second if statement nested inside the first if statement. It sequentially tests from left to right. The first step determines if the purchase quantity is less than 100 or not. If true, it applies 1% and stops. If false, it moves on to the second if statement test if the quantity purchased is between 100 and 250 or not. If true, it applies 2%, but if it's false, then it applies 4%. Now let us replace hard-coded values with cell references as per the best practice. I've stored quantity 100 and 250 in cells F2 and F3 respectively, and replaced 100 and 250 with cell references F2 and F3 in the nested if statement. The final nested if statement will look like this. Now, I'm going to fix cell references for F2 and F9 and copy the formula down the column till D16. Let us check if the formula is applying the discount rate correctly or not. The discount when ordered quantity is 249. It should be 2%. We see the formula, and yes, it is computing the correct value. Finally, we need to compute the price after the discount. The price after discount will be the list price multiplied by 1 minus the discount. So here in cell E9, I will write a formula for price after discount and copy the formula down to other cells. Now, you can see the price after the discount for all purchases. In this video, I'm going to introduce the use of the AND function while nested if statements. In learning exercise 11.1, we've already created a nested if statement for discount application to bulk purchases. In learning exercise 11.2, we will add a condition to discount application viz, whether the client is new or old. An additional condition states that the clients who have been loyal to the company should get an additional discount. The cell range B1 to D5 has a discount structure, and the cell range A8 to C16 has order ID, quantity, and client status. Let us construct a formula in cell D9. The first step is to determine how many if conditions we need to determine the discount rate. We need one if condition to test quantity purchased is less than 100 units or not. If less than 100, we need an if condition to test if client status is new or old. And if more than or equal to 100, we need an if condition to test if client status is new or old. In total, we need 3 if conditions. In cell D9, I will construct a formula without using the AND function inside the nested if statement, and then contrast this with the formula with the AND function. The formula tests if cell B9 value is less than 100. If true, it will test if client status cell C9 is new. Apply 1% discount else. Apply 1.5% discount. If false, it will test if client status in cell C9 is new. Apply 2% discount, or else apply 3% discount. Let me write the formula by replacing discount with cell references and press enter. Let me copy the formula down to D16. Now, let me rewrite this by using the AND function. We need one if condition to test quantity purchased is less than 100 units and client status is new or not. We need another if condition to test if the quantity purchased is less than 100 units and client status is old or not. We need one more if condition to test if the quantity purchased is more than 100 units and client status is new or not. In total, we need 3 if conditions. So the number of if statements remain the same with or without AND conditions. In cell E9, let me construct the formula using the AND function. If cell B9 is less than 100, and if client status in cell C9 is new, if the outcome is true, then apply 1% discount. If false, test if cell B9 value is less than 100, and if client status in cell C9 is old. If the outcome is true, then apply 1.5%. The outcome is false, test if cell B9 value is more than 100, and if client status in cell 9 is new. If the outcome is true, then apply 2% discount. If the outcome is false, then apply 3% discount. Let me write the formula by replacing discount with cell references and press enter. Let me copy the formula down to D16. Both if statements with AND condition and without AND condition require 3 tests. Both use a nested form of if statements. However, you can see that if statements with AND conditions are easy to match condition and outcome assignments, whereas the same in if statements without AND condition is not quite easy. In learning exercises 11.1 and 11.2, we covered nested if statements. In this learning exercise, we will introduce a new function, IFS, which is relatively new in Excel. IFS is simple, and I recommend you use it. Cell range A8 to B16 has purchase orders, and we must apply a discount rate as per the discount policy. This time, we are going to use IFS functions instead of the if function. Let me write the formula in cell C9. enter equals IFS, open parentheses, and click on FX. You will see a dialog box with two input fields, logical test 1 and value if true 1. You can add logical tests by clicking on the bottommost field. Logical test is the Boolean expression. Value if true is the assignment to the true outcome. Either you can enter the value directly or point the value field to a cell reference that holds the value. In logical test 1, I'm going to enter B9 is less than 100. Either I can click on cell B9 or type cell reference B9. Clicking reduces error chances and hence is considered superior. And in value if true 1, I will enter 1%. This results in IFS statement IFS open parentheses B9 less than 100, comma 1%, close parentheses. The moment I click on the field value if true 1, a new field logical test 2 gets added. This is because the IFS statement takes multiple logical test conditions. In the field value if true 1, let me replace 1% and refer to cell C4 and then make it an absolute reference. Notice that IFS statement has no separate assignment for the false outcome. If the test outcome is false, IFS statement does not assign anything and moves to the next test. Next, let us add logical test 2. The logical test 2 tests if cell B9 value is between 100 and 250. This test has two conditions. B9 is greater than or equals to 100 and B9 is less than 250. We must use AND operator to make sure the cell B9 value fulfills both conditions. Therefore, I will enter AND open parentheses B9 greater than equal 100, comma B9 less than 250, close parentheses, in logical test 2. And in the field, value if true 2, refer to cell C5 and then make it an absolute reference. Next, let us add logical test 3. Let me enter the third condition, B9 greater than or equal to 250 in the cell. Now, we must add value if true 3. At times, value if true 3 may not be visible. If invisible, scroll down to view it. In value if true 3, refer to cell C6 and then make it an absolute reference. Click on OK. Now let me replace quantity values with references. I will replace 100 with E2 and 250 with E3 and make them absolute references. The final step is to validate whether the IFS is evaluating correctly. Here, the quantity sold is 90, which is less than 100, and its corresponding discount rate should be 1%. Let me copy the formula down the column. The quantity sold, 249, is between 100 and 250, and its corresponding discount rate should be 2%. The quantity sold is 250. The corresponding discount should be 4%. You can find that the formulas are applying the discount rate correctly. In this video, I'm going to introduce conditional aggregate functions like Countif, Sumif, Averageif. The cell range A2 to D20 has transaction data. Column B has employee name, column C has items purchased, and the amount spent is in column D. In cell J5, we would like to compute the total number of transactions done by John. To do this, we will use the Countif function. Let me select J5, write equals, Countif, open parentheses, click on FX. Here, you can see that the Countif function takes two arguments. The first argument is the range of cells that needs to be counted based on certain conditions. The second argument, named criteria, is the filter condition for counting. Let me start with range. We will select cell range B3 to B20. We should not select the table header now. The criteria should be John. Ideally, you should encapsulate a string within double quotes. However, even if you don't do so here, Excel will understand and add double quotes before and after John. Let me show you. So, the total number of transactions is 7. Next, let me show you how to use the Sumif function. In cell J6, we have to compute the total amount spent by June. Let me select J6, write equals, Sumif, open parentheses, click on FX. Here you can see that the Sumif function takes 3 arguments. The first argument is the range of cells on which the condition has to be applied. The second argument, named criteria, is the filter condition for summing the data. The third argument, named SumRange, is the range that is summed. Let me start with range. Since we are computing the sum spent by June, we will select range B3 to B20. The criteria should be June. We should type June. We should not refer to the cell where June is present in the dataset, that is B4, because the dataset can change. The sum range should be the amount spent range, which is D3 to D20. Now click OK. So the total amount spent by June is $875. Next, let me show you how to use the Averageif function. In cell J7, we have to compute the average amount spent on conveyance. Let me select J7, write equals Averageif, open parentheses, and click on FX. Here you can see that the Averageif function takes 3 arguments. The first argument is the range of cells on which the condition has to be applied. The second argument, named criteria, is when the data in the range is selected or filtered. The third argument, named average range, is a range that needs to be averaged. Let me start with range, since we are computing the average amount spent on conveyance. We will select range C3 to C20. The criteria should be conveyance. We should type conveyance. The average range should be the amount spent range, which is D3 to D20. Now click OK. So, the average amount spent on conveyance is 204.6. In this video, I will introduce multiple conditional aggregate functions like Countifs, Sumifs, and Averageifs. In cell H5, we would like to compute John's total number of transactions on conveyance. Since there are 2 conditions, one on the name column and another on the item column, we will use the Countifs function. Let me select H5, write equals, Countifs, open parentheses, and then click on FX. You can see that the Countifs function shows 2 arguments, but the arguments will increase the amount we add criteria 1. Let's take the employee name range as the first criteria range, B3 to B20, and John as criteria 1. The criteria range 2 will be item cell range, C3 to C20, and criteria 2 will be conveyance. We don't have any other conditions, hence I will click OK. So John has done a total of 2 conveyance transactions. In cell H6, we would like to compute the total amount spent by June and on snacks. We can compute the Sumifs function. Let me select H6, write equals, Sumifs, open parentheses, and then click on FX. Here, you can see that unlike the Sumif function, which had the sum range as the third argument, the Sumifs function has the sum range as the first argument, so you can set additional criteria without any issue. Since we are computing the sum of the amount spent, the sum range is D3 to D20. Let me select it. The criteria range 1 can be either the employee name or item. Let's select employee name, range B3 to B20. Next, let's enter June as criteria 1. Now, select C3 to Z20 as the criteria range 2 and enter snacks in criteria 2. Now click OK. So the total amount spent by June on snacks is $339. In cell H7, we would like to compute the average amount spent by Mark and on conveyance. We can compute the Averageifs function. Let me select H7, write equals, Averageifs, open parentheses, and click on FX. Here you can see that unlike the Averageif function, which had the sum range as the third argument, the Averageifs function has the cell range as the first argument. Since we are computing the average amount spent, the average range will be D3 to D20. Let me select it. The criteria range 1 can be either employee name or item. Let's select employee name range B3 to B20. Next, let's enter mark as criteria 1. Now, select C3 to C20 as the criteria range 2 and enter conveyance in criteria 2. Now click OK. So the average amount spent by mark on conveyance is 224.5. In this video, I will introduce multiple conditional aggregate functions like Maxifs and Minifs. Note that there is no singular counterpart to Maxifs and Minifs. We can use these plural functions to compute the maximum or minimum value for a single criterion also. In cell H3, we have to compute the maximum amount spent by June. Let me select H3, write equals, Maxifs, open parentheses, and click on FX. The first argument is the max range. It should be the range whose maximum value needs to be computed. Here, it will be a mount column range, D3 to D20. Let me select it. The second argument is criteria range 1. It is the range on which we apply the criteria condition. Here, it will be the employee name. Let me select B3 to B20. Lastly, I will enter June as the criteria 1. I'll click OK, and so the maximum amount spent by June is 299. Next, let's see the application of Minifs for a single criterion. We need to compute the minimum amount spent by June. Let me select H4, write equals, Minifs, open parentheses, and click on function. The first argument is the min range. It should be the range whose maximum value needs to be computed. The first argument is the min range. It should be the range whose minimum value needs to be computed. Here, it will be a mount column range, D3 to D20. Let me select it. The second argument, criteria range 1, is the range on which we apply the criteria condition. Here, it will be the employee name. Let me select B3 to B20. Lastly, I will enter June as the criteria 1. I'll click OK. So the minimum amount spent by June is 105. Next, let's apply Maxifs for 2 criteria. We need to compute the maximum amount spent by June and on snacks. Let me select H5, write equals, Maxifs, open parentheses, and click on FX. The first argument will be the amount range, D3 to D20. Let's select it. The criteria range can either be employee name or item. Let me go with item. Its range will be C3 to C20. Now, I will enter snacks as the criteria 1. The criteria range 2 will be employee name. Let me select B3 to B20. Now, I will enter June as criteria 2. Next, I will click OK. So the maximum amount spent by June on snacks is 234. Now let's implement Minifs for 2 criteria. We need to compute the minimum amount spent by June and on conveyance. Let me select H6, write equals, Minifs, open parentheses, and click on FX. The first argument will be the amount range, D3 to D20. Let me select the employee name as the first range, as it will be B3 to B20. Now, I will enter June as the criteria 1. The criteria range 2 will be item. Let me select C3 to C20. Now, I will enter conveyance as the criteria 2. Next, I will click OK. So the minimum amount spent by June and on conveyance is 84.